This is what you need to know about probability. Our statistics course is not all about probability, but probability is the foundation for inferential statistics. We could spend a whole semester or two on probability, but I just want to give you what I think you need to know. In our daily lives, we hear about probability all the time. For example, there's a 20% chance of rain. The chance of you or me winning the Powerball is 1 in 150 million. There's a 50% chance of coming up head when you flip a coin. In mathematics or statistics, we don't like to use the word chance. Probability, though, is often called the science of chance behavior. Chance implies or infers uncertainty or unpredictability, and that's not what probability is about. A very simple definition of probability is that it is used to describe the likelihood that an event will occur. The result of the event is often called an outcome. For example, you flip a coin 100 times, that is 100 separate events, but the outcome is whether you want heads or tails. I like to refer to probability as a proportion, the proportion of times that something occurs. In statistics, the important thing to remember is chance behavior in the short run is unpredictable, but in the long run has a regular and a predictable pattern. And referring to flipping a coin flips are memoryless. You might flip 10 in a row and get heads 9 out of 10 times. But we know that in the long run, the more you flip the coin, the more likely you are to flip heads 50% of the time or tails 50% of the time. In statistics, the word random or randomness doesn't mean haphazard or chance. It refers to the kind of order that emerges in the long run. The basic formula is P equals the number of ways an outcome can occur and divided by the total number of possible outcomes. For example, if you want to flip a coin, if you want to achieve heads, how many ways are you going to achieve a head of a coin flip? 1. What are the possibilities? Divided by 2. Probability always varies between 0 and 1. So if there's a 0 probability of something happening, that means nothing's going to happen. 1 is perfect. We seldom get to perfect. Probability is always, or usually at least, referred to in terms of a percentage. For example, suppose you have 100 clients. Only one is Native American. If you randomly select one client, what is the probability of that client being Native American? That's going to be 1 over 100 or 0.01 or 1%. Again, I hope this helps you, but think of probability as also a proportion, the proportion of times that an outcome will occur. Just like looking at a fraction or coming up with a fraction. Statistics, for probability, we have to have two things. First of all, you have to have random sampling, which is everyone has an equal chance of being selected. Secondly, you have to have something called sampling with replacement. If more than one individual is selected, probability must remain constant for all selections. That means every item that is selected is then returned to the population and thoroughly mixed with the population so you can continue to draw items. For example, to describe sampling with replacement, think of a deck of cards. And what are the odds of drawing a jack of diamonds from a deck of cards? There are 52 cards in the deck, so the odds of drawing a jack of diamonds since there's only one jack of diamonds, is 1 divided by 52. So you draw your first card and it's not a jack of diamonds. So now you have 51 cards left. What are the odds of drawing a jack of diamonds? The odds are 1 divided by 51. In sampling with replacement, we put the first card back, so you're always drawing from the full deck. That's all it means. Now we're going to move to using z-scores and the unit normal table to determine probability or proportion of area under the normal curve. An example is, let's say you have IQ scores that form a normal distribution with a population mean equal to 100 and a standard deviation equal to 15. What is the probability of randomly selecting a student with an IQ score less than 130? Another way to put it is, what proportion of those students would be under 130? First, convert your 130 to a z-score. Z equals x, the value, minus the population mean divided by the population standard deviation. In this case, 130 minus 100 equals 30 divided by 15 equals 2. That's a positive 2, so you know that you are 2 standard deviations above the mean. I often find that it's helpful to diagram it. So draw a normal curve, put your mean, your standard deviation, and then go to your unit normal table. Locate the z-score of 2.00, and then, because we're looking in the body, we want to know what proportion is in the body, so you look in column B, and you will see that 0.9772 or 97.72% would be less than 130. There's a third way you could describe it by referring to it as a percentile, which means that 97.72% got below 130. Let's do a couple problems. Drivers pay an average of a mean of $690 per year for auto insurance. The distribution of insurance payments is normal curve with a standard deviation of $110. What proportion of drivers pay more than $800 per year? I was going to do this in class, so I had work it out in groups, but obviously we can't do that. The second part of the problem is, what is the probability of randomly selecting a driver who pays less than $600 per year? For the first part of the problem, we're going to convert to a z-score. So we're going to take 800 minus 690, divide by 110, equals 110 divided by 110 equals a positive 1.0. Below that, I've diagrammed drawing a normal curve. We know that 800 is 1 standard deviation above the mean, so we want to know that area greater than 1 standard deviation. If you go to the unit normal table, look in the z-score column for 1.00, and then look in the tail, which is column C, which is that area greater, and you'll see 0.1587, which is 15.87%. 15.87% pay more than $800 per year. We do the same process or procedure for part B. We convert to a z-score, 600 minus 699. Sorry, I meant 600 minus 690. And you have a negative 69 divided by 110. And that gives you a z-score of negative 0.63, rounded off. Go to your z-score table, your unit normal table in the z-score column, and find 0.63, and look in column C for the tail, and you will see 0.2676 or 22.76% below. Now I haven't drawn it for you, but if you want 5 points extra credit, draw the normal curve for this part B of the problem and send it to me by email or attachment. And that's really all we're going to talk about regarding probability at its basic. Next we'll move to doing things with more than one sample, where all of the samples for a given n are the same, and we'll talk about confidence intervals.